Hello everyone, this is June 2024 and this is paper 2 for Edexcel. Right, let's have a look at question 1. Nice straightforward one to start us off with. It says find in its simplest form dy by dx given that y is equal to that expression there. So y is equal to 4x cubed minus 7x squared plus 5x minus 10. So therefore dy by dx is equal to 12x squared minus 14x add 5. Okay, that's part 1. The second derivative, d2y by dx squared, we just differentiate it again. So that gives us 24x minus 14. And then part B, it says, hence, find the exact value of d2y by dx squared equals 0. So we just take the second derivative, put it equal to 0, and rearrange it for x. Super straightforward question there. Let's look at question 2. Jamie takes out an interest-free loan of £8,100. Jamie makes a payment every month to pay the loan back. Jamie repays £400 in month 1, £390 in month 2, £380 in month 3, and so on, so that the amount repaid each month forms an arithmetic sequence. Show that Jamie repays £290 in month 12. So we have here an arithmetic sequence where the first term A is 400, and the common difference is 390, take away 400 is minus 10. So basically Jamie's paying back £10 less each month. The nth term of an arithmetic sequence is given by un equals a plus n minus 1 times d. Our a is 400, our n in this case is 12, and the common difference is 10. So basically in month 12, Jamie's going to be paying back £290. Now, after Jamie's nth payment, the loan is completely paid back. Show that n squared minus 81n plus 1620 equals 0. Okay, so basically, because there's no interest, the total sum that's paid back is the principal sum, in other words, the amount that Jamie borrowed, which is our 8,100. So what we need to do is put 8,100 as our sum into the sum of an arithmetic progression formula. So you're given, remember we're given this one in the formula booklet, which is super nice. So you have n over 2 times by 2a plus n minus 1 times d. Now in this equation, the only thing we don't know is the n. So I've chosen to start off by multiplying both sides by 2 and expanding my brackets. So times everything by 2, and 2 times 400 is 800n. And then I'm going to have n times minus 10 is minus 10n squared. And n times 1 minus 1 times minus 10 is plus 10n. So then I get the whole thing over one side, which gives me 10n squared minus 810n, and then divide that whole thing by 10, which gives me n squared minus 810n plus 1620 as required. Part C, hence find the value of n. So that's nice. We've just got to now solve this equation for n. So let's just solve this equation for n now. So it factorizes. Again, we can use our calculator to like reverse engineer this. Yeah, super useful thing to know. Let me just show you how we would do that. I've got a bit of an old-fashioned calculator here, but hopefully it's equivalent on the up-to-date ones. So I'm going to go to 2 polynomial. It's degree 2, so it's a quadratic. And I'm just going to put that quadratic in there. So we've got 1n squared. Then we have minus 81. And then we have press equals, and then we have plus 1620, and then you can see that you get 45 and 36 as your two solutions from which you can reverse engineer the brackets. So kind of like a nice little technique there for making sure you get a mark for showing that you factorized it. Now that means that because it's a quadratic, it's going to be the lower of the two values, so it's going to be 36 is going to be how long it took Jamie to pay back that loan. And that's question 2 done. Quite a nice question. Question 3, we have here graph transformations. Always important, graph transformation questions. Let's have a look at this one. Now the point P, it says, lies on a curve with the equation y equals f of x. Find the coordinates of the point P. Find the coordinates of the point to which P is mapped when the curve with the equation y equals f of x is transformed to the curve with the equation y is equal to f of x minus 2. So f of x minus 2, this is a translation by minus minus 2. So it's a translation by vector to 0. So the whole curve is going to move 2 to the right. So the x-coordinate is going to increase by 2. So that's going to give us the point 5 minus 2. Number 2, f of 2x. This is a stretch of scale factor 1/2 parallel to the x-axis. So that means if something's stretching parallel to the x-axis, then what that means is that the x-coordinates are going to halve. So what was formerly the point 3 minus 2 has become 3 over 2 minus 2. The last one, there's a lot going on in the last one, a number of transformations for our 3 times f of minus x plus 5. Now, I always think that BODMAS is the way to do this. So BODMAS, BODMAS, or you might have learnt it as BIDMAS. Okay, there we go. Yeah, right, so let's have a look at how we're going to do this. So in other words, we're going to do the order of operations. So let's do what's in the brackets first, okay? So this f of minus x is a reflection in the y-axis. So that would cause the coordinate 3 minus 2 to become minus 3 minus 2, because the x-coordinate is going to be change sign. So we've done that bit. Now let's work out and do the multiplication. So now it's time for the 3 times. And that is a stretch of scale factor 3 parallel to the y-axis. So when we stretch something by scale factor 3 parallel to the y-axis, the coordinate that was minus 2 is going to become minus 6 because the whole curve gets stretched that way. So we've done that one, and this is where we're up to at the moment. And then finally, the plus 5, that is a translation of 5 units in the positive y direction, meaning that the whole graph is going to move up by 5. So where was at 3 minus 6, it's going to go to minus 3 minus 1. So that's our final coordinate. So the key handy hint there is to think about the correct order of operations for that one. Question 4, what have we got? A little bit of recursive iteration. So a sequence U1, U2, U3 is defined by un add 1 is equal to 5 times, is equal to k times un minus 5. And the first term in the sequence is 6, where k is a positive constant. Given that u3 is equal to minus 1, show that 6k squared minus 5k minus 4 equals 0. Okay, so if u1 is equal to 6, let's just generate the first few terms. So the second term, u2, is going to be k times u1 minus 5. So u2 is going to be 6k minus 5. So that's our second term. So u3 is going to be k times u2 minus 5. So u3 is going to be k times 6k minus 5, which when we expand that bracket gives us 6k squared minus 5k minus 5. And the question tells us that u3 is equal to minus 1. So I've replaced that with minus 1. And when we take that whole thing over to one side, we get the expression that we were required to derive for part A. Quite nice. Okay, part B, hence find the value of k. So I think they're really just implying there that we should solve this quadratic. So we can factorize it using the method that I discussed before, reverse engineering it from the calculator. And we get 2 possible values of k, 4/3 or minus a half. But the question tells us that k is a positive constant, so we can exclude that value. We can discount or exclude that value. Finally, find the summation from r equals 1 to 3 of ur. Now, there's not going to be any sort of like particular summation formula that's going to work here because of the way we've got this recursive iteration. So I think the best thing to do is just actually add up the 3 terms. So the question told us that the first term was 6. The question told us that the third term was minus 1. We have a formula for u2. We know that u2 is 6k minus 5. And we now know that k is 4 over 3. So we can just sub that in to what we already know. And from that, we can work out our value of sigma r equals 1 to 3 of ur. Perfect. Right, that's the first 4 questions. Am I going to do the next one? Oh, I'll do this next one as well before in the same video. Okay, question 5. Given that theta is small and in radians, use the small angle approximation to find an approximate numerical value of that expression there. So again, the good thing is that in our old friend, the formula booklet, let's have a look, we're given these small angle approximations. So sine theta is approximately equal to theta, cos theta is approximately equal to 1 minus theta squared over 2, and tan theta is approximately equal to theta. So let's just keep those visible there so we can see them. So let's see, theta is measured in radians. So our original expression, theta tan 2 theta over 1 minus cos 3 theta, is going to get replaced by theta times 2 theta, because tan theta is approximately theta, so tan 2 theta is 2 theta. And this bit sometimes causes some confusion. 1 minus cos 3 theta is going to be 1 minus, and cos theta is 1 minus theta squared over 2. So 1 minus, and notice, instead of theta, we've got 3 theta. And notice the whole thing is in the brackets squared, okay, over 2. A common error I'll put here, this is what it is not. This, I'm just showing you, let's put a huge cross through this just so we know this is an error, yeah? So this would be a common error that people would write 3 times theta squared. It's 3 theta altogether. So that helps us a little bit with our simplification. So what have we got when we remove our brackets? 1 minus 1, they're going to cancel out, and minus 1 times minus 1 is going to be plus. So they've cancelled, and we end up with 2 theta squared over 9 theta squared over 2. And dividing by a fraction is the same as multiplying by its reciprocal. So when we multiply that out, that's going to give us 4 theta squared over 9 theta squared. So our theta squareds are going to cancel, and the numerical value of that particular expression is going to be 4 over 9. Okay, perfect. So that's that one done. Yeah, I think what I'll do is I'll call that a day on that video. I hope you found that helpful. I'll continue the rest of the questions for this paper in the next video.